Sheet metal fabrication is everywhere, from brackets to electronic enclosures. For engineers, designing is just the start. Clear communication with fabricators is crucial. This happens through technical drawings using standardized conventions. Without these, mistakes, delays, and costly errors are inevitable. A good sheet metal drawing gives fabricators all the info they need: material, thickness, shape, and bend details. Clear drawings ensure parts are made right the first time, keeping projects on track. Standard conventions speed up manufacturing and reduce costs by eliminating confusion. Poorly detailed drawings slow everything down and risk errors. Mastering these conventions shows professionalism and respect for the manufacturing process. In today's competitive market, clear, concise drawings set great engineers apart. They're the foundation for reliable, high-quality products. The flat pattern view is the heart of any sheet metal drawing. It shows the part as a flat, unbent shape, essential for cutting and fabrication. Bend lines, marked as dashed or phantom lines, indicate exactly where to bend the metal. Accurate placement of these lines is critical. Even small errors can ruin the part. The flat pattern also helps spot design issues, like features too close to bends. Efficient nesting of flat patterns reduces material waste and cost. Always include overall dimensions for the blank. This helps with material selection and quality checks. A clear flat pattern bridges the gap between raw material and finished part. Bending metal stretches the outside and compresses the inside. Enter the K-factor. The K-factor helps calculate how much material is needed for accurate bends. Get it wrong and your part won't fit. Always specify material thickness clearly, in decimals and gauge if needed, to avoid confusion. Bend notes tell the operator the direction, up or down, and angle of each bend. Include inside bend radius, if it matters for fit or strength. These details, K-factor, thickness, bend notes, remove guesswork and ensure precision. The right info lets fabricators set up machines correctly the first time. Precision here means the final part matches your design. Cutouts like holes and slots must be fully dimensioned from key edges or datums. Keep features away from bend lines to avoid distortion, at least 2 to 3 times the material thickness. Specify edge treatments. Round sharp corners, add reliefs, and include notes like deburr all edges. For special edges, hems, or rolled edges, add detailed views and dimensions. If the part is part of an assembly, call out all hardware and use standard symbols for welds. Surface finishes, like powder coating, should be clearly noted. These details ensure the part is safe, functional, and ready for assembly. Missing them can lead to parts that don't fit or fail quality checks. A thorough drawing covers everything from first cut to final assembly. Professional drawings are clear, complete, and organized. Use at least 3 views: isometric, orthographic, and flat pattern. Label views and place dimensions logically. Avoid clutter. The title block should list part name, number, revision, material, thickness, and designer. General notes cover tolerances, deburring, and finishes. Stick to one standard, ASME or ISO, for consistency. Always review your drawing as if you're the fabricator. Can you make the part with no questions? Peer reviews catch mistakes and ensure your drawing is truly fabrication ready.